All right, 11.1 video notes. This whole chapter is talking about circles, much more in depth than, so far we've learned area and circumference and some things about radius and diameter, just really basic parts, but we're going to go into a lot more detail on this section. So let's go ahead and let's jump right into it. So 11.1 is all about tangent lines. So first we should probably define it and give some examples. So a tangent is a line that intersects a circle at exactly one point. Okay, so it's a line that intersects a circle at exactly one point. So I'm going to draw a line in here, and boom, and I just nick it right there. So this blue line right here, this would be called the tangent line. That's an example of a tangent line. And this red dot right here, that point is what's referred to as the point of tangency. All right, so we're talking about when something just barely nicks the edge of a circle like that, 1 point. So there's basically two theorems that we're going to use today when solving some problems. So I'm going to go ahead and scroll down here. And the biggest one, kind of the very first one here, is that let's just say that we have a tangent line flying in here. Boom. And let's say right here is our point of tangency. Well, if you connect the center of a circle and you draw a radius, so I draw a point from a radius from the point of the center to the tangency point, the big idea here is that creates a 90-degree angle. Always. The radius and the tangent line always meet at 90 degrees. So let's just kind of draw that over here. So this theorem has to do with perpendicular or 90 degrees. A radius is perpendicular to the tangent line at the point of tangency. So big thing is radius perpendicular to the tangent line. Now that opens up the door for a lot of things like Pythagorean theorem and things of that nature. So let's kind of go down and do a couple examples here. So example 1 says determine if line AB is tangent to the circle. Well, the only way I can do that is I have to check to see if and let's put a C here for the center of the circle. Let's just check to see if the measure of angle A is 90 degrees. If it is, then I know I have a tangent line. Well, how do you check to know if that's going to be 90 degrees? So what I'm going to do is I'm going to test the Pythagorean theorem. If a squared plus b squared equals c squared, then we have a 90-degree angle. So let's test it. Couple things that I need to kind of be careful of here. So what I'm checking is I'm checking to see, let's just call this right here our little b, and let's call this, all right, well, I guess I don't really have to call it A or B. Those are just the legs, and we're thinking, we're not sure yet, but we're thinking that might be 90 degrees. So my two legs are 11 and 12. So I have 11 squared plus 12 squared. And now I'm asking myself, I don't know this yet, but I'm asking, is that equal to this line squared? Now I have a little bit of work to do because I don't know how long that line is. I know how far 4 is, but 4 only goes from here to here. Now the one thing that you need to know on this type of problem are that all radii are equal, meaning that if this piece right here is 11, this piece right here is 11. So that should allow me to find that whole side. It's basically 11 plus it's basically 11 plus 4. So 15 is this far side. And let's check it out. So I get what's that, 132? Check that, 121 plus 144, which is 265. And then over here, 15 square, well, that's only 225. So they're not equal, so it is not a tangent line. All right, that's not a tangent line. Now, if it would have been equal, then I would have been good. All right, let's try the next one. The next one says find the missing segment lengths, and we are going to assume that we have a tangent line on this one. We're going to assume that, yes, we have a tangent line. So I got to make this thing work out. So ultimately, I'm trying to figure out x. Since this part is 12, I know this part is 12. This whole side out here is going to be 12 plus 8, or 20. So it looks like I know two sides, but I'm missing this piece right here that we're going to call x. And we know that this is 90 degrees, so we can use the Pythagorean theorem. So x squared plus 12 squared equals 20 squared. X squared plus 144 is 400. X squared equals, when I subtract from both sides, I get 256. Square root, and I get x equals 16. So again, I'm using that whole idea of a tangent line being perpendicular to a radius, which opens up the door for Pythagorean theorem or SOHCAHTOA. So number 3, find the missing angle measure, and there's a hint there that says use isosceles triangles. So again, I have to assume that I have a tangent line. That probably should have been in the directions, but that line right there is tangent. Okay, so because of our previous theorem, we know that this is 90 degrees. Now I'm going to start using some other pieces of information that I have. I know that this angle plus the 114 adds up to 180 and makes a straight line. So subtract 180 minus 114 and I get 66 degrees right here. Now because this is a radius and this is a radius, that's isosceles. So I should be able to use that to find out these two angle measures. So I'm going to do 180 take away 114, and that means I have 66 degrees left. But I need to divide that by 2, and I believe I get 33 degrees for each of these angles, 33 degrees. And that will allow me to find this big angle right here, because that has to add up to 180 with 33. So 180 take away 33 is 147. So this is 147. And now I can kind of use a quadrilateral formula. So let's focus your eyes right here. That's got 4 sides. So the sum is 360 degrees in all quadrilaterals. So far I have 90 plus 66 plus 147. So that's 3, carry the 1, 16. So right now we're up to 303. So subtract from 360, because that's what I need to be a quadrilateral. And so it looks like the final answer here is 57 degrees. That was kind of a tougher one, kind of a challenge problem. All right, second theorem. So this is kind of the second key point or big idea from this set of notes. And it kind of looks something like this. If you have two lines, so let's say there's some point out here, and I draw a tangent line, and then I draw another tangent line, okay? So if two tangent lines share an endpoint, all right, and the endpoint is right here. So those two tangent lines share an endpoint. Then they must be congruent, okay, or equal length. So I know that this line is the same length as that line, if they're both tangent lines and they share a point. So for example, it says example 4, find the perimeter of the polygon. Well, so basically, if this is 5.5, this one has got to be 5.5 because these are two tangents that share a point. If this one is 7.4, this one is 7.4. If this little piece right here is 8, this little piece right here is 8. And now the only thing that's not accounted for are these two little pieces right here. Those are two baby little tangent lines. And what I'm going to do is I'm going to subtract 10 minus 8, and I'm going to get 2 and 2 for those two guys. So now I should be able to add up the perimeter all the way around. It's basically, well, let's see what I got. I got over here, I got 9.4 for that side. Here I have 10. Coming this way, I have 13.5. And then coming this way, I add these two up, so that's 12.9. So now I add up all those guys all the way around, and I believe that comes out to be 45.3 when it's all said and done. All right, number 5, let's solve for x. So since these two lines right here, that's a tangent and that's a tangent, a couple things I know that it's 90 degrees with the radius, so it's actually a 90-degree kite here, but I do know that this equals this, so I can use my algebra and I can say 1 plus 3x has to equal 2x plus 4, and solving it, subtract 2x from both sides. I get 1 plus x equals 4 minus the 1 from both sides, and we find out that x equals 3. So pretty quick notes today. Those are your two theorems. Hopefully that's enough to get you rolling on the practice. See ya.